Thanks everybody for coming here today to listen to my inevitable talk about Nix that often comes up, often had come up while I was working as an RSC with ICCS. Yeah, glad to be back, if only briefly, talk about this. I've been playing with Nix. It started as a hobby a yearish ago. I moved from Arch Linux to NixOS, which is an operating system that uses bits of Nix. And I've stuck with it because it's not been overly problematic. I'm not shilling for them here, nor do I'm not a core Nix dev. I've done a bunch of contributions because it's really easy to contribute to, but I'm not super into the behind the scenes stuff here. I want to give a couple of ideas of places that you might want to use Nix, why it's useful in some ways, and a bunch of the drawbacks that I've found over my time using it. So yeah, quick overview of the sort of stuff that we're going to go over in the next half hour, 40 minutes. I want to talk about Nix relevant stuff that's also relevant to RSEs primarily. I keep talking about, I will say reproducibility way too much because it was the only thing people talked about when we were trying to, when we work on new projects that need work, we always say make it reproducible. And Nix has lots of things it can do for us there. So if we have time, I'll talk about a tiny bit of, we'll talk about we'll get slightly more technical and talk about writing Nix derivations, which is kind of like a build script. I think here we'll kind of just wing it and we can go over and look at some code if it's interesting. Otherwise, we'll talk about some NixOS stuff, which is a bit more specific. So yeah, if anything, if I can get a couple of people to come away from this knowing of Nix and knowing of problem areas where it can be applied and it might be useful, then I'd be very happy with that. I don't want everyone to go straight to Nix and experience all of the pain I have, because it's not, well, because part of this is partly, well, this is fun for a hobby, but it's also partly, I'll talk about it a bit later. I have actually managed to apply Nix to help one of the ICCS directors with setting up some Docker stuff. I'll talk about it later. I shouldn't be spoiling it here. So, why do we care about software reproducibility? The problem is the phrase that we've heard probably quite a lot. We've probably also said it ourselves as well. There are many steps to building and running software, and any tiny difference between two environments. I'm going to primarily talk about compiled software here because it's the most convenient to talk about when you're thinking about build environments versus runtime and such. But this more or less applies to interpreted language as well in a slightly harder to see way. But let's say we're trying to reproduce some results from building and executing some program. There's a bunch of ways that our environments could differ. So for building, we might mess up the source archive that we were intending to use. Maybe you had a problem when you were downloading and you missed a file. Maybe you got the wrong version in the first place. Maybe the versions have been retagged on GitHub and you've downloaded the wrong one. Probably the worst one here is unidentified dependencies, where there's actually something else that you need when building this project, but it doesn't come with, or it's always been on the author's system, so they didn't count it as a dependency. It wasn't identified properly. An obvious one is architecture. Building the same software on different architectures may result in different behavior. This ties in quite a lot with compiler, because same compiler on different architectures may well be different. The same compiler a couple of versions apart may be semantically different. Even the same, even a like patch version of the compiler may end up producing semantically different programs if there was a bug that was fixed or not fixed between them. It's not too fun to imagine that changing your compiler might actually change your output, the behavior of your output. And even if you get all of the build environment stuff the same, and you're happy that you've done this correctly, you've set up everything as the original author did, you've still got to worry about runtime environment, because if you're using shared libraries, then you have to make sure that you have the same shared libraries that they were using, or your runtime might be different. And that's really irritating, because usually you can only have, usually the way that we do shared libraries on Linux is you can have one of each major version of a library installed at once. It's a bit funky. It depends on how you're linking these things, but the default is that you link for a major version, and it can be horrible. It's or maybe they don't version their ABI well. I've mentioned, I've got here. Yeah. So the solution to the hell of not being able to reproduce someone's build environment is to write a script, whether it be automated or manual. Clarify your build environment, identify dependencies. Automation, I think, is always nice here because it means there's fewer ways for you to do something, for a human to do something wrong and miss a step. So identify dependencies as well. That I mentioned, there can often be some unidentified stuff. A key one is in software in particular. Perhaps you need some licensed data to build your software, and you can't pass it. You can't keep it with the rest of the code in some public GitHub, for example. So you can, as long as you put some notes in your build script, perhaps you can automate this. Perhaps you just have to say, please download this tar from this website and abide by their licensing. Then it's a solution in some way. You've made it idiot-proof, IP. Yeah, the problem with shared libraries doesn't really get fixed here because the key point is the global nature of shared libraries, which really can just make it can make testing programs on an existing system overly problematic. If you need an older version, for example, the classic case is if you need an older version of some system library like curl, then good luck, because if you have a newer version, your system might not be able to might not let you install the older version, or the newer one will get loaded instead when you try to use the older one. So our reproducible build script can't really handle that too well, but otherwise we're happier now. We've maybe applied some CMake or some GNU auto tools to a project that previously didn't have it, and we're comfortable that we've run it on a bunch of different systems, some different architectures, and we seem to get the same results when we run things. So there are a couple of different subsets, I guess, of reproducibility. There are some more specific terms I think that we could use. One that I like to say, I like to use is software reproducibility, which is, as RSEs, I think we often talk about reproducibility, also including scientific reproducibility, being able to not just the build process and the running process, but also including kind of, this is how you configure your experiment and obtain results that we expect. Software reproducibility is none of that. It's just given a set of inputs, the sort of thing that a package manager would take in, basically, each of these things, we should be able to generate the same output every time. So it should be, the output should be determined by the set of inputs. In reality, we have poor sandboxing, so it can be hard to get this perfect. It can be possible usually to do it fairly well, but I think the key thing is we often don't care too much about exact build tools to get used when we're building these things, because you end up having to use your global tool chain or whatever. So finally, we get to talk about Nix. Nix to me asks the question: what if we sandbox everything all the time and never let you do anything that you didn't explicitly mention? So I'm not going to show you any of the Nix build scripts for now, but what I want to talk about is what binaries look like in Nixland, as opposed to what they look like on any other Linux or Nix-like system or Nix system. Oh no, I said Nix. What's the word that we use for Linux/Mac? Sorry, Unix. Unix. On any other Unix system. This first point is more of a package manager point than anything. But your builds may only use explicitly stated dependencies. We have this build script that we call a derivation, and Nix will build that derivation in a sandbox where it cannot access anything that wasn't specified as an input there, which means things like any of your system libraries, even libc has to be, the exact version of libc that you're using has to be specified. This sounds really tedious, but the way that you write these derivations is not so, thanks to lots and lots of abstractions. So yeah, there are no external dependencies in Nix. This is fantastic for reproducibility. This is how Nix obtains its actual determinism in builds. You can, given a set of our input, we always get the same output, which means we can do content addressing of our built derivations, and we get lots of convenient things from that. There's a massive drawback here in that you have to do everything in Nix, and if a project is architected in a way that's less easy to adapt, then it's going to take much more effort to utilize Nix with it, as opposed to doing it in a regular package manager or a regular build system that doesn't do the weird things that do here. Cool. The other thing, the other big difference for binaries in Nix is there are no shared libraries. There is no global loading of, there's no user/lib on my NixOS laptop. This is a bit technical, but it's really fantastic. I just found this out, and I'll actually run a command in a sec to show you. Yeah, a given derivation will always load the same shared libraries, or it will fail to load. And it does it by setting the R path. I've got a quick command here. So I knew about this, and I didn't know exactly how it worked for the longest time. Yeah. Here we go. readelf will let us look at a specific part of the elf header in this, so that the executable information of, we're going to look at grep. This is where my grep is. I'll prove it to you. If I do which grep, oh no, which grep doesn't work. But if I do bash, then which grep is this. So we run this readelf command. I'll make my text a little bit smaller. And here we have it. We see there's two, actually first I'll do LLD because this is much easier to read the output. Right, LDD tells us which shared libraries are referenced, which libraries were linked with this executable. You can see libpcre and libc, they get resolved some crazy path, which we don't care too much about. But we scroll up and we see that actually they're written in their regular format, but the run path has the has both of those packages, which is how it gets around not having a global library store. And I knew it worked somehow, but I didn't actually know that's how it works. Very, very funky. This does also importantly mean my computer can't run executables built on a different OS because I don't have a global library store. So and the run path is usually going to be, our path has a default as well if it's not set, I think. So it would look in userlib, and it doesn't. I don't have userlib. So yes, Jack.
So does this mean if you had 2 different sandboxes, you would potentially have 2 copies of grep, or a copy of grep for every sandbox you have?
No, because Nix content addresses all of its derivations, and it can figure out if you've built grep once. Let's go back actually onto here, and I'll do which grep again. No, hold on. LDD. How do we find this? We'll cheat. We'll go. We'll bin it. Oh no. Okay. This is why. This run current system path is almost certainly a symlink, and it's a symlink to a right. So I'm going to introduce a bit of terminology that I've not explained super well. But this massive path, starting with that /nix/store, is a derivation, which is I think I use the same word for both. This is a built package that's stored in the Nix store, which means it's installed on your system. Let's say, I guess you had 2 programs which needed grep. If both of them ended up using the same grep input, so we're using the same libc here and we're using the same libttre, then both of them would they would say, okay, I need this grep. In any case, they would end up saying, oh, I need the grep that has this content hash. And it would go to the Nix store, it finds it, and if it's already built, it doesn't need to rebuild it again. The kind of the content hash store is how Nix does all of its storage efficiency, basically, because you can have a bunch of the same library installed on your computer. However, if all of your programs are only using one version of that library, then it will only build it once, and there'll just be a bunch of symlinks every time you need, if you need things loaded in a certain way. Of course, there's no, my path actually, this is another example, I guess. My path won't have any of the, user bin, because that doesn't exist, well, it has one thing, or /bin, because both of those just have 2 things, I think, for fixing things if things break. So yeah, binaries in Nixland look totally different, and it's a little bit weird, and there's good reasons for it. This shared library stuff is one of the key things they did with Nix, actually, that they spent a lot of effort on. There is a program that can, I think, adapt existing executables to work like Nix, which is one way to get around the problem I mentioned earlier of the hell of, if you want to use Nix, everything you use has to be in Nix. There's some things that we can try to fix there, and yeah, there's been a mountain load of developer effort. Okay, so cool. I've introduced some problems in reproducibility, what software reproducibility in particular is, and how we would love determinism in our software reproducibility. So Nix is a terribly named piece of software because it's a bunch of things. Nix is a package manager that also does tons of other stuff. It's your derivations are written using a functional language. Conveniently, this language is also called Nix. And NixOS, which is in the title of this talk, is an operating system which uses the Nix package manager. Yeah. So the primary thing that we're interested, though, when we talk about Nix, is the package manager. They didn't have to. The Nix language is also super interesting, but it's more of. I think it was more of. It was designed in order to support the package manager rather than it being any outstanding, unique design by itself. It largely just works with the package manager and makes things makes derivations convenient to write. Otherwise, it would be horrible. So, as you'd expect with any package manager, derivations may depend on other derivations. I mentioned I haven't added it to the slides, but there's a you only will build a given derivation one time, and if when Nix package manager is resolving a bunch of dependencies and it finds that you've already built or you already have installed certain derivations, then it doesn't have to go build them again. There is also a system for downloading derivations from a trusted provider. This is something that doesn't really exist in, I think, most package managers. Nix kind of has two modes when you're trying to install something. It does them both automatically, mind you, but you can set up a something called a substitutor, where every time you try to build a derivation, Nix instead goes to check on the internet at a cache that you've configured, and it says, do you have the derivation at this content hash? And if it says yes, then you download that and you're sorted, and you don't have to build it by yourself. If it doesn't have it, then instead it checks the dependencies, it downloads or builds all the dependencies, and then it does it itself. This is the magic of Nix, because it means you can install a like not very well used program in about 10 seconds, because you either download it immediately or you download a tiny bit of code and immediately compile it with the GCC pre-installed on your system. It doesn't pollute any of your global folders and stuff. This is definitely some of the magic, and it makes Nix super good for doing development work. So cool. I focus on the package manager thing for Nix because some of the alternatives, in quotes, to Nix might be things like Docker, and then the Ubuntu-ish Snap and Flatpak. I don't know too much about the first two, but I see those as essentially big binary blobs. They can't interact with anything outside them. They're well sandboxed. It's kind of like doing a statically linked build for Windows users. You're not getting any of the benefits of shared libraries, which there are benefits. And importantly, none of those three tools have very useful, can't say this for Snap and Flatpak. Docker doesn't have good tools for building Docker images because it's not a package manager, even though your Docker images will use packages that are installed on your system. The kind of disconnect between your own package manager and the thing that's building your binary blobs can be quite troublesome when you're aiming for reproducibility, and Nix finally bridges that gap properly in a way that I don't really think. I think that other programs have tried, and I'll talk a tiny bit more about Docker in a tiny bit. It feels a lot more complete Okay, a bit more on the drawbacks that I've already mentioned. So writing a new Nix derivation for a project that doesn't already use any Nix stuff can be really irritating because it's kind of like another build system on top of your existing stuff. It can be, depending on how complex the thing you're trying to build is, depending on how many different external dependencies it needs, and so on. It can be a lot of work, and it can feel like a bit of a waste of time. I think you have to kind of know what you're getting out of building something with Nix to bother. So I had, do I mention it here? No. I had a project that I wanted to start, and for that I needed an executable program that wasn't on Nix, and I thought I'll have a go making a derivation myself. It turned out it was going to be way too much effort, and really there is a workaround, and it's using some arcane magic that lets me run executables as if they were on Nix without actually having to write stuff. You can still run snap and flatpak stuff on Nix as well. So sometimes it's not worth it. Yeah.
When you say run it on Nix, do you mean NixOS now, or do you
I
mean
meant NixOS. Sorry. Yeah.
And with Nix, you can install Nix in theory on any flavor distribution of Linux, or
You can actually, yes. I've not mentioned it, but the Nix package manager kind of works standalone because it stores everything in, all of your packages are in /nix/store. Sadly, it has to be there for reasons. But as long as you have read and write access to that, you can install Nix. You just have to change your user path.
sure.
But that's more or less it. I did do that.
So you would need, on a system, you would need root access because it would need access to that directory. You can't
Yes. Yeah.
install it as an ordinary user.
Yeah. I think there are instructions for installing on an existing Linux distro is you have to make a bunch of build users because the way that it does its builds derivations parallel needs a bunch of extra users. I think it's to do with C groups and stupid stuff. Yeah, it's very possible, and it works nicely. But really, if you're doing that, then you're probably just haven't found good enough. You're probably just not allowed to install NixOS, or you have a good reason that like certain software that you need doesn't play nicely with Nix at all. So you're sticking with your current distro and using Nix on top. Using Nix on top of an existing one, you just need lots more storage because now you kind of have two different libcs and you have two different libcs on your computer and two different sets of programs that are using them. So it can balloon. Okay. Oh yeah, this is what I mentioned. Non-Nix dependencies are hard to handle. I've said this enough. Yeah, no, this is just the truth of Nix, and I'll talk a tiny bit. Yeah, we'll get there. Some kind of sub ecosystems of Nix have tons of support, and this second point becomes completely moot because it's immediately really easy to work with like any software written in that ecosystem. So Haskell is fantastic in Nix. You don't really have to think about anything. A bunch of people are working on this stuff constantly, and it just work. It's kind of probably best in class. It's probably easier to use than Haskell on any other OS. So I've kind of alluded to this, but the lock-in that you end up making on Nix is a bit disappointing, personally. If I build my software and I set it up so that I can build it with, I can build a Nix derivation of it, I can't just give that to somebody. I could give, if they were a Nix user, I could say, okay, just build this derivation, and they would either build it or they'd download it from my substitutor or whatever. That doesn't work so well for non-NixOS users. However, you can very easily build Docker images using Nix. yeah, easier than Docker itself. And it's, I think, highly logical to do so as well. So this doesn't feel as bad. So I know I've shat on Docker earlier, but my issues with Docker is the building. Okay, this was a point that I've got to remember because somebody made fun of me online for this, and I think it's probably, I guess it's important to know, but I've been talking about derivations in Nix being content addressed. So a given derivation has a set of inputs. We know when we build that derivation, we get an output that we can hash it in some way, and we always get the same hash, and that's what we use for that's our content address. I'm not fantastic with the words there. The way that we, let's say we're trying to build program X, in the dependencies list, we can see Y, we can see derivation Y with a certain content address. The way that we figure out what to build there is we go to our massive freaking catalog and we see please get me this derivation, tell me all about it. Can I download it from somewhere, or do I have to build it myself? If you have to build it yourself, it then has to go through the dependencies there and such. And yeah, that works by going through a massive catalog that's currently about 40 megabytes. And of course, if you can still build old programs as well, old programs. You can still build old derivations which aren't in the main catalog anymore because it's all version controlled with Git. So I think you end up having a lot of catalogs on your system. And I just wonder, because this might be an unsolved problem in the Nix ecosystem. There are a couple of things that, like, I think people are hoping that we'll figure out in the future, thanks to, so far, the flexibility of Nix and the Nix language. So, yeah, that's interesting. In theory, I guess if that catalog went down, if you didn't have, if somehow all of that vanished from the internet, you wouldn't be able to build things anymore. But that's not really, that goes for everything else. And another thing that people have complained about before, there are no security features. When I've talked about this substitution feature where you have a derivation, and rather than building it yourself, you go to your local cache provider and you say, can I please have this derivation? There's no security stuff done there. When I'm talking about content hashes, they're not cryptographic anyway. This is a feature. They've made it clear that the substitutors thing doesn't do any kind of guarantees. It doesn't come with any guarantees that what you're downloading was properly built. The actual wording in the wording in my NixOS config is something like trusted substitutors.
There's no way they would ever support anything like that.
I don't know. I have no idea. I can't imagine that anyone would categorically, that the Nix people would say categorically, we're never going to do any security features for binary substitutors. I wonder if there's like an especially a problem that's hard to solve there, and so they haven't done it. It may well be that there's just not enough people who are interested, and it hasn't been worked on so far.
But could you, suppose you wanted to be sure in your builds, could you download the derivations and build them all yourself?
Yes. Right. You can think how, if anyone has done a compiler theory university module here, then you could imagine actually there's quite a lot of work to do. If you want to build everything, you've got to do quite a lot because you have to build your compiler, but you need the compiler that built the compiler and the compiler that built the compiler and stuff. I don't remember the name for that. It's an X problem. It's the compiler problem. It's the bootstrap problem. Nix has a solution for the bootstrap problem that's good enough. It goes really far down, and then I think it downloads a known binary from somewhere. It depends on what compiler and then everything you're using. So the answer is yes, you can.
Okay, yeah.
Yeah, I've done something similar where I need a specific Haskell compiler. This isn't really the same as GCC because Haskell compiler uses GCC. But here I would be like, can I please, I would press a button that would say it would say build my Haskell project with this compiler. And the first thing it would do is make me sit at my computer for 30 minutes while it builds the compiler. I was really glad it worked one time. Usually it crashes my computer because I run out of memory. There are bad things for this. Right, so I'm gonna skip this because I don't think the build script thing is too interesting. We can get back to it, but I wanted to talk about the Docker stuff that I've been alluding to. Right. Docker is really, really fantastic for sandboxed applications. Yeah, end of story. It's really good for that. It's really hard to build reproducible Docker images, in my experience. You might have a reproducible. You might have your project set up in a convenient way where it's clear what dependencies you need and such, and you should be able to build something deterministically. But if you then try to place that, in a Docker image, the problem is you usually don't have any control over the build tools that you use when building a Docker, when using a Docker file, building a Docker image. So my understanding was that this was why Docker brought in this feature called build stages, where you can say start this container from a base Ubuntu image, which contains a bunch of tools already that we know about in theory, and they're versioned. Build the project and then only copy the built artifacts into the output container. It's something like that. It's horrid, and I don't think. I think if you want to, for example, you want to make two builds of your application. One is regular, one's for Ubuntu, and one's a Docker image. Then I think you have no choice but to build it twice sometimes. Yeah, it's irritating. I don't have good. I can't. I might be lying to you if I go into too much detail there. But let me show you a quick snippet of some Nix code. So here we've got something called Granule. It's on GitHub. It's a functional programming language. It's a compiler along with a bunch of other stuff written in Haskell. We needed a Docker image that included most of the parts of this, and would definitely run on your average Linux system. I think they were having issues, and it can sometimes be a pain. I remember what they were doing. So they've had a Docker file before. I don't think it looks very good. They have to do a bunch of stuff. We're doing wgets here to download Z3, and we download like a specific. Where do we even get GHC? I don't know. It's messed up. We have to do all of this. It feels very weird to me. It feels very weird to put this in a Docker file. We're putting package manager instructions in our Docker file. It kind of goes to show. So then I'm going to click on our Nix file here. There's lots of stuff here that we don't want to, that I won't introduce, but this kind of declaratively defines how to build the Granule project using inside Nix, how to build a derivation for it, and at the bottom, I have a special package that preps a Docker image for free. there is almost nothing that I actually do here. There is a name line which doesn't count. There's a tag line which gives it the Git revision. There is one whole line of configuration in order to generate a Docker image, a minimal Docker image for the granule that we build in Nix, and it's purely saying make the entry point an executable that we've built earlier in a different derivation over here. Just by saying that, Nix can figure out, oh, okay, I need to build this derivation in order to build the Docker image. It builds this first, and then the Docker image gets built just with a magic command that somebody has done a ton of work on. And essentially, we have a Docker file in this much, except really it's 2 lines. And it's also minimal because it only includes conveniently a given Nix derivation, tells you exactly what you need to run the next Nix derivation. I've actually been conflating build time and runtime a bit when I've been talking about when we're building stuff and running stuff in Nix. But yeah, Nix knows exactly what you need runtime as well as build time for anything that we build. So when I say when I set the entry point to something that we built earlier, it knows that it needs to build it and it needs to include all of the runtime dependencies. And that's it.
So as in it only includes what it needs to run rather than another Docker image which could have all of Ubuntu.
Yeah. Yeah. And then the Docker build stages does have a solution for not including all of that Ubuntu stuff in it, but it's so clunky. And it feels bad to have to kind of do the same thing twice a lot of the time in Dockerland when building images. So yeah, I think it's very fair to say that if you're thinking about using Docker, if you're thinking about building a Docker image for something that's and you need good reproducibility for some reason, like you can always now go back to this and build the same Docker image, even in a year. It's not always useful, but it's interesting. So yeah, Nix is fantastic for this, and this actually solved a problem as well where we where their old Docker file wasn't working. They had a bunch of stuff. Z3 is a pain to set up, I think, on Linux by default, but luckily Z3 already exists on Nix. People have already done derivations for it, and there's actually no reference of Z3 at all here. Because of more Nix interop that works behind the scenes that I won't get into. So sometimes things can work very well, and you get free Docker images with something like this. So it was worth. I'm glad I looked into this in particular, doing Docker images in Nix, because it saved us a lot. It saved me a lot of hassle for in a couple of things. Especially in high school. I should wrap up and take questions and stuff, but I'm going to quickly mention NixOS and talk about it in a tiny bit more detail if I didn't before. Nix is a package manager. NixOS uses that package manager and adds a bunch of configuration and stuff on top of it. To also allow you to specify a full operating system. This is a big script. It's so much easier to talk about this just by staring at the code, because this doesn't look like code at all. This looks like it looks like nice Ansible. Let's go modules. Let's go sys. Okay. Which one's the recent one? Yeah, great. I'm going to have to go into another one in a bit as well. Let's go. So, yeah, this is a really cool thing. The Nix language is, what is it? Functional? There's also another word that's relevant. There's a word that's used in languages,
Declarative?
declarative, thank you.
That's Dominic.
Thank you. Yeah, that often comes along with functional. Nix is a declarative, the language is declarative, which really lends itself to defining systems, both user and you can also use this for servers and such as well. It's kind of like a thin, it's kind of like a basic provisioning system. So I have a massive repository here that provisions my, it provisions this laptop. I think I've deleted this one because it got old. But it provisions my laptops and it configures various things that I know I don't want to change. For example, this one is my Pichu. This computer is maybe Pichu, maybe it's a different one. It's separated into a bunch of modules. Let's look at hardware sys, because we can look at how the Linux kernel's all set up. Sure, that'll do. Yeah, fantastic. And then this is a small little like nugget of my system config, which sets up a bunch of services. It uses the latest Linux. I set my host name. I set up a couple of. I install a couple of things by default. I set up my audio properly, which was what somehow got us working immediately with this new setup without having any issues. This then all gets tied in with Nix as a massive derivation, along with there's then a couple of other NixOS specific tools that like use that derivation to set up your root file system. But yeah, you're able to, NixOS lets you declare your computer config very nicely. This sort of thing's been done a bunch. This isn't really very new, because you've got things like Ansible, Salt, Chef. You've then got things that were more specifically server tailored, like Terraform to an extent, and so on. Oh, of course, even Docker did its own thing, Docker Swarm. Kubernetes kind of is a bit relevant here as well. But the key thing is that they are all a bit more siloed. They're usually interested, so Kubernetes and Docker are interested in containers. Ansible is fairly hacky, and you have to kind of cross your fingers every time you use it. Nix keeps doing this fantastic thing where it's got tendrils and everything, and they've figured out no tendrils go far enough to talk about most of the bits that make up an operating system, and you can use it extremely well for that. One of the interesting things that comes with this is, since you're building your system as a derivation, you can roll back your system fully if something goes wrong. So if I were to restart my laptop now, it actually shows me, the boot manager shows me a list of generations from like current one is 40, and then if that doesn't work, then I can just scroll down and I can run an earlier version of my system, which has come in handy. So yeah, NixOS definitely a kind of hobbyist thing, but it's cool. It's cool, and it's very interesting. It's taught me a little bit. It's helped me do some. Everyone loves to do this sort of configuration on their laptops, and my dot file started getting out of control when I tried to do too many things. NixOS helped me bring it, make it a bit more sensible. Right. So I think I'll stop there. Links mostly for myself. Please may I take any questions if anyone had stuff to.
Yeah, thank you for that. That was actually super interesting. Really good. There is one question that came in online that I will give precedence to, which is Julian asked, what about SPAC? Which I suppose you partly answered with the bit on NixOS and Docker. But yeah, do you have any comments on how Nix versus SPAC, where you can sort of specify versions?
I think I've used SPAC a tiny bit, and I think I noted when I was playing with it how it like there's a module, at least on CSD3, and I think this was SPAC. There's a module system where loading modules actually edits your path environment variable and maybe some other environment variables, which means when the same command actually uses different programs. That concept is handled better in Nix, where you can, for example, let's say that you had modules between Python 2 and Python 3, and you were running Python every time. So if you load Python 2 module, you run Python, it's Python 2. If you load the Python 3 module, you run Python, it's Python 3. Nix is probably nicer there because you can always be explicit and run. Yeah, there's no state. Importantly, Nix doesn't have the same statefulness as SPAC, where you load a module and now you're in this mode. You can run it statefully if it's useful to you. You can kind of say, I think Nix does its sandboxing a bit better, but I shouldn't really comment too much on it because I don't know too much about SPAC.
Okay.
I think that they're both relevant. They do the same sort. I think they both try to tackle the same problems.
Yeah, Julian said thanks. Dominic confirms that it makes very small Docker files. So yeah. Any questions in here, or any other questions online?
So, hello, can you hear me?
Yes. Yeah.
So, what happens when one of the libraries that everything depends on gets a security update?
In that case, you would hope that you can rely on your substitutors, because if that happens and the Nix package's global catalog gets updated, and you say, please update my system. So there's usually a separation. If you're using NixOS, there's usually a kind of a big layer of system stuff that you always want, as opposed to like my NeoVim, which isn't part of that. Then you would hopefully download that new, that updated library, and all of the programs that you're using would hopefully be already built on your substitutor, and you can just download them. Hold on. But if we're talking about this, if that's a shared library and it's, I don't know.
I mean, doesn't everybody have to go and do a lot of work to update their little part of the universe to have the right hash again?
I think so. There's a small chance that there's a Nix tool that I mentioned. I didn't say the name, but PatchElf is the Nix tool that helps mess with R paths in order to fix up non-Nix executables into Nix executables. I think there might be some integration that uses PatchElf so that you don't have to re-download it. So that maybe you can take an existing derivation and just update the R path for a given shared library. That's a possibility.
I guess you could alternatively just hack around with the content address store and make it not a content address store anymore, and have symlinks out to the place where the feature compatible but secure new version lives, I suppose.
That would probably destroy things in bad ways. They tell you not to do that. They tell you not to ever remove files from the store. You can remove a whole derivation, but you shouldn't change things. You always can, but I think you have a good point there. I think that might be one of the downsides.
Feels like someone has probably thought about this
Almost
So
certainly.
there's probably something online.
Yeah, I didn't talk about it, but there's a bunch of HPC interest in Nix, and more specifically Wix, which is the GNU, the GNU kind of version. And I know that they've tackled a bunch of, I suppose, much more RSE relevant problems in my own stuff. I'd imagine that's come up, but yeah, I don't know too much. I don't know too much there. I'd be quite curious actually to kind of know.
Okay, thanks.
So I have one quick question, but we should probably draw it to close, which was just, is it sort of, if people wanted to get started on using this, is it possible to put sort of, where would I go to look at putting the Nix package manager on my existing Linux system and having a play around?
Yeah. All you need to do is head to nixos.org. Take a look at the instructions for installing on an existing Linux distro. You need root access, but otherwise, I've done this before ages and ages ago, and you can install Nix on top. As long as you put it first in your path, then you'll be using your Nix tools where they're found. And it's also, there's no way that you can screw up your system because everything gets stored in that global /nix/store. If you want to remove Nix, then you just remove
RMR. Yeah.
So yeah, take a look at NixOS.org if you're curious.
Excellent. In that case, yeah, we are slightly over time, so we'll wrap it up there. Thank you once again, Ben, for coming to speak to us about that. And please do join us, everyone, next week